Hey there, this is Mr. Wolf, and today we'll be going over benchmark 17. This is our special right triangles. Benchmark 17 says I can apply the side relationships for 30, 60, 90 and 45, 45, 90 triangles. And we've got an image of each of those right here. These are the only two triangles that the rules that we're going to talk about apply to. So really a pretty simple benchmark once you boil it all down. To start off, just a quick reminder of our Pythagorean theorem. You'll remember that Pythagorean theorem is something like this. Let's blow that up a little bit. And let's add in a crucial piece here. That's a squared plus b squared equals c squared. And you'll remember that the c side is always our hypotenuse, our side that is opposite from the right angle. A and B can be either one of the legs, it doesn't matter. But as long as you get C as the hypotenuse, you'll be good. All right, every one of our formulas is derived from the Pythagorean theorem, so that's why I wanted to hit that first. Let's start off with 45, 45, 90 triangles. And I've got a series of them here. You can see this first one here is actually 1 by 1, and this one's 2 by 2. We've got 3 by 3, and so forth. Let me just label a couple more here. 5 by 5, and we'll go to 6. Let's actually start with 6. Let's go. Okay, so you'll remember if we use Pythagorean theorem, we can solve for the long side or the hypotenuse for each of these triangles by simply doing a squared plus b squared equals c squared. Now, for our example, let's start with this one right here. Okay. In this case, we have A and we have B, both of the legs, since this is a right triangle. So we're going to plug in 2 squared plus 2 squared, and that's going to equal our long side, our hypotenuse, which we'll just leave as c squared since it's unknown. Okay. When we solve that, we get 4 plus 4 equals c squared, and that equals obviously 8c squared. And you'll remember that the very last step we have to do is to square root both, because we're not interested in c squared, we just want to know what c is. Okay, so we square root both. Of course, c squared square rooted just takes us right back to c. And you'll remember that in order to simplify radicals, we have to break them down into their factors. In this case, we would have 4 and 2. And then 4 can be broken down into 2 and 2. We circle our pairs because pairs come out from underneath the radical. So we end up with a 2 on the outside, and what's left is this lonely 2 here, and that stays in the radical. So we figured out that our long side C right here is actually, and I'll write it right here, 2 radical 2. Okay? So let's try that again. This time we're going to let's try this triangle here, 4 by 4. And we would just do the exact same thing. 4 squared plus 4 squared equals c squared. Okay? And of course that's 16 plus 16. And that's going to be 32. And we split that up into a pair of factors. I like 16 and 4. Excuse me, 16 and 2. So we can break 16 up into 4 and 4. And even though 4 will break up, those are already a pair. So we can just stop here and save ourselves a little work. And we're left with a pair of 4s, which go on the outside. And radical 2 stays on the inside. So then we just figured out that this long side here is 4 radical 2. Now, it's worth pausing here to note the pattern that we see. When this leg here was 2, the hypotenuse was 2 radical 2. When this leg was 4, the hypotenuse was 4 radical 2. I'll bet you could guess that this hypotenuse here is going to be 5 radical 2. And this one down here, of course, will be 6 radical 2. So the pattern that we notice is that we take the leg, multiply it by radical 2, and we get the hypotenuse. All right? So let's take another look at it. You've got two ways to solve. Here's a problem here. Leg is 7, so we know this leg over here is also 7, and we want to find the hypotenuse. So you got two choices. You could do the Pythagorean theorem. And if you did that, you would have to do all these steps that we just did. A squared plus b squared is c squared. Square the numbers, add them, square root, simplify the radical, and you come down and you get 7 radical 2. But if you note the shortcut, you knew that you just took the leg and put a radical 2 on the end, and you're done, like they did over here. And it's already simplified, so that's a nice way to do it. So let's do a couple quick practices here. So since this side is 7, we're going to multiply by radical 2. And let's see here. So you know that x is going to be 7 radical 2. Done. Let's go on here. This time we're given, well, aren't given a leg, we're given a hypotenuse. And if you'll remember back here, to go from leg to hypotenuse, we multiplied by radical 2. Well, now we're going the other way. We're going from hypotenuse to leg. So guess what we're going to do? We're going to divide by radical 2. Okay? And if you'll remember from class, we never leave a radical in the denominator. So we have to do what's called rationalize the denominator by multiplying the top and the bottom by radical 2. And we end up with 3 radical 2 over radical 2 times radical 2 is just simply 2. Just removes the radical. Okay, so that's how long the leg would be. Let's try another one here. We've got 12, and 12 is the hypotenuse. So when we're going from hypotenuse to leg, we have to divide. So we're going to do 12 over radical 2. And when we simplify, when we rationalize that denominator, we multiply top and bottom by radical 2. And that gives us 12 radical 2 over 2. And we can simplify that even further because we can do 12 divided by 2. That's 6. And we're left with our radical 2. So 6 radical 2 is our solution. All right. So let's just skip forward here. And we'll come back and review those in just a moment. Right now, we'll want to do 30, 60, 90 triangles. So we're going to be changing up a little bit. What I've got here are several equilateral triangles. And I started with an equilateral triangle because that's where we get the 30, 60, 90 triangles. So you'll remember that in an equilateral triangle, each of these angles is congruent to one another. In fact, they are all 60 degrees. Okay? So let's go down here and let's try, I like this one. This one happens to be 4 by 4 by 4. Okay? And I think what I'll do is just redraw that and make it a little clearer for you. Let's see, where's our equilateral triangle? There we go. Alright, so let's label those sides again. 4, and that side's 4, and this side's 4. Everybody agrees those are all 4, and each of these angles is 60 degrees. Alright, but I'm going to draw a line. Okay, I'm going to draw a straight line. This is actually called an altitude. It will divide our triangle in half, right? And it also creates a right angle right here. Okay, so you'll remember that the angle down here, of course, was 60. All right. This angle up here was 60, but we cut it in half. So half of 60 is 30. And you know a right angle is 90. And that's where we get our 30, 60, 90 triangle from. It's just half of an equilateral triangle. All right, we already knew that this length here is 4, and this side happens to be the hypotenuse of the triangle. Okay, we're going to call this leg, since it's the shorter leg, we'll call it the short leg. And we'll call this leg here, since it's the longer leg, we'll call it the long leg. All right, this side here is going to be real easy to find. We already knew this whole side was 4. And since we cut it in half, we know that this piece right here is going to be half of 4. So it's 2. So finding the short leg is really easy if you know the hypotenuse. You just cut it in half. Okay? And we also have a shortcut to figure out how to find the long leg. And to spare you a little bit of time and explanation, the shortcut is to take the short leg, which is 2, and multiply it by radical 3. So our long leg is 2 radical 3. Okay? So I guess the easy way to remember is that half the hypotenuse equals the short leg, or we could say 2 times the short leg equals the hypotenuse. Okay? We could also say that the long leg is equal to the short leg times radical 3. Or we could say that the short leg equals the long leg, not times, but divided by radical 3. All right, let's skip forward and look here at a couple examples. So this is basically what we all just said. We identify the sides as hypotenuse, long leg, and short leg. And those are easy to find. You'll remember that the hypotenuse is across from the right angle. The short leg will be across from the smallest angle, and the long leg will be across from the 60-degree angle. All right? And these are the shortcuts we just learned. I would write this down, maybe pause right now and jot these formulas down, because this is all you have to know for this benchmark. A couple of practice problems here. Here, okay, we're given which side. This is the long side, so this is the hypotenuse. And we already learned that the shortcut is take half the hypotenuse, and you get the short leg. So our short leg will be 7. Okay? And if we want to go from short leg to long leg, we just multiply by radical 3. So we just put a radical 3 on the end, and we're done. And that's pretty easy, right? And we can confirm here our answers are the same, and you can see how the problems are worked out. All right, something a little harder. This time we're given the short leg. So to go from short leg to hypotenuse, you'll remember that this is half the hypotenuse. So if 6 is half, then the hypotenuse has to be 12. And the long leg, we just take the short leg, which is 6, and multiply it by radical 3. And these confirm that our answers are correct. The hardest problem you're going to encounter is when they give you the long leg, okay? Because to go from long leg to short leg, we have to divide by radical 3. And you'll recall that we do not like it when we have a radical on the denominator. So we'll have to rationalize that denominator, okay? And that looks something like this over here. So to go from the long leg to the short leg, okay? Actually, I'm going to cover those up. We're going to do 8 over radical 3. We're going to times both top and bottom by radical 3 to rationalize the denominator. And we get 8 radical 3 over 3. That is our short leg. And to find the hypotenuse, all we do is double it. And what's easy about that is we really only double this number here. So we get 16 radical 3 over 3. Okay? So the only number we have to remember for 45, 45, 90s, radical 2. You're either going to times or divide by it. The only two numbers we have to remember for 30, 60, 90s are 2 and radical 3. And you're either going to times or divide. All right? And this is our shortcuts here. To find the hypotenuse, and I would pause right here to write these down. These are for 45, 45, 90s. Okay, these two formulas here, that's all you need for 45, 45, 90s. And if I scroll down, these are your shortcuts for 30, 60, 90s. And I would jot these down if I were you. Okay, so let's sum up. In order to do 45, 45, 90s, radical 2, either times or divide. And in order to do 30, 60, 90 triangles, you're going to use 2 or radical 3, and you're either going to times or divide. It's really simple. All right. There is a really short quiz to take after this. The link is below in the comments on the YouTube page. As always, if you're really confused or stuck, you can text me at the text number, which is right here. Okay. You can email me. You can visit my website where I've got lots of resources to use. But make sure you complete the quiz to demonstrate that you did watch the video and you do understand how to do benchmark 17. Okay. Thank you for listening. Look forward to seeing you next time. Mr. Wolf, signing out.